Hello and welcome to a lecture on ice creams. Let us understand the manufacturing of ice cream. The basic steps in the manufacturing of ice cream are generally as follows. Number 1, blending of the mix. Number 2, pasteurization. Number 3, homogenization. Number 4, aging of the mix. Number 5, freezing. Number 6, packaging. And number 7, hardening. Number 1, blending of the mix. The ingredients are selected based on the desired formulation and the calculation of the recipe from the formulation and the ingredients chosen. The ingredients are weighed and blended together to produce what is known as the ice cream mix. Blending requires rapid agitation to incorporate powders, and often high-speed blending are used. Generally, the hopper devices are used for the blending of ice cream. Number 2, pasteurization of mix. The mix is then pasteurized. Pasteurization is a biological control point in the system designed for the destruction of pathogenic bacteria. In addition to this very important function, pasteurization also reduces the number of spoilage organisms such as psychotrophs and helps to hydrate some of the components. Batch pasteurizers lead to more whey protein denaturation, which some people feel gives a better body to the ice cream. In a batch pasteurization system, blending of the proper ingredient amount is done in large jacketed vats equipped with some means of heating, usually steam or hot water. The product is then heated in the vat at least 69 degrees Celsius and held for 30 minutes to save legal requirements for pasteurization necessary for the destruction of pathogenic bacteria. Various time temperature combinations can be used. The heat treatment must be severe enough to ensure destruction of pathogens and to reduce the bacterial count to a maximum of 100,000 per gram. Following pasteurization, the mix is homogenized by means of high pressures and then is passed across some type of heat exchanger for the purpose of cooling the mix to refrigerator temperatures 4 degrees Celsius. Batch tanks are usually operated in tandem so that one is holding while the other is being prepared. Automatic timers and values ensure the proper holding time has been met. Continuous pasteurization is usually performed in a high temperature short time heat exchanger following blending of ingredients in a large insulated feed tank. Some preheating to 30 to 40 degrees Celsius is necessary for solubilization of the components. The HTST system is equipped with a heating section, a cooling section and a regeneration section. Cooling section of ice cream mix HTST presses are usually larger than milk HTST presses. Due to the preheating of the mix, regeneration is lost and mix entering the cooling section is still quite warm. Number 3, homogenization of mix. The mix is also homogenized, which forms the fat emulsion by breaking down or reducing the size of the fat globules found in milk or cream to a less than 1 micrometer. Double-stage homogenization is usually preferred for ice cream mix. Clumping or clustering of the fat is reduced thereby, producing a thinner, more rapidly whipped mix. Meltdown is also improved. Homogenization provides the following functions in ice cream manufacture: reduces size of fat globules, increases surface area, forms membrane, makes possible the use of butter, frozen cream, etc. by helping to form the fat structure. It also has the following indirect effect: makes a smoother ice cream, gives a greater apparent richness, better air stability, increases resistance to melting. Homogenization of the mix should take place at the pasteurizing temperature. The high temperature produces more efficient breaking up of the fat globules at any given pressure and also reduces fat clumping and the tendency to think heavy bodies mixes. The higher the fat and SNF in mix, lower the pressure should be. If the double-stage homogenizer is used, a pressure of 2000 to 2500 psi on the first stage and 500 to 1000 psi on the second stage should be satisfactory under most conditions. Double stage homogenization is usually preferred for ice cream. Clumping or clustering of the fat is reduced, thereby producing more rapidly whipped mix. Meltdown is also improved. Number 4. Aging of mix. The mix is then aged. This allows time for the fat to cool down and crystallize, and for proteins and polysaccharides to fully hydrate. The functions of aging are to improve whipping qualities of mix and body and texture of ice cream. The mechanism of action is by providing time for fat crystallization such that fat can partially coalesce, allowing time for full protein and stabilizer hydration, and a resulting slight viscosity increases, and allows time for membrane rearrangements and protein emulsifier interaction, as emulsifiers displace proteins from the fat globule surface, which allows for a reduction in stabilization of the fat globules and enhanced partial coalescence. Aging is performed in insulated or refrigerated storage tanks, silos, etc. Mix temperature should be maintained as low as possible without freezing at or below 5 degrees Celsius. An aging time of overnight is likely to give best results under average plant conditions. A green or unaged mix is usually quickly detected at the freezer. Number 5. Freezing or whipping of ice cream. Following mix processing, the mix is drawn into a flavor tank where any liquid flavors, fruit purees or color are added. The mix then enters the dynamic freezing process, which both freezes a portion of the water and whips air into the frozen mix. The barrel freezer is a scrapped surface, tubular heat exchanger which is jacketed with a boiling refrigerant such as ammonia or freon. Mix is pumped through this freezer and is drawn off to the other end in a matter of 30 seconds with about 50% of its water frozen. There are rotating blades inside the barrel that keeps the ice scraped off the surface of the freezer, and also dashers inside the machine which helps to whip to mix and to incorporate air. Ice cream contains a considerable quantity of air, up to half of its volume. This gives the product its characteristic lightness. Without air, ice cream would be similar to a frozen ice cube. Number 6. Hardening. After the particulates have been added, the ice cream is packaged and is placed into a blast freezer at -30 to -40 degrees Celsius, where most of the remainder of the water is frozen. Below or above -25 degrees Celsius ice cream is stable for indefinite periods without danger of ice crystal growth. Above this temperature, ice crystal growth is possible, and the rate of crystal growth is dependent upon the temperature of storage. This limits the shelf life of ice cream. Hardening involves static freezing of the packaged products in blast freezer. Freezing rate must still be rapid, so freezing techniques involve low temperature with either enhanced convection or enhanced conduction. The rate of heat transfer in a freezing process is affected by the temperature difference, the surface area exposed, and heat transfer coefficient. Thus, the factors affecting hardening are those affecting rate of heat transfer. Now, let us further move to the defects of ice cream. Ice cream defects are generally traceable to some identifiable cause, which should be included in the surveillance and control measures assigned to quality assurance. However, gross abuse of the product may occur beyond the sphere of a plant's control, in which case little can be done other than to attempt to educate those involved. There are several criteria which may render a product unacceptable. Failure to meet legal composition, high standard plate count or coliform count, weight below the legal minimum, serious flavor defects, serious body and texture defects, serious defects in appearance of both products and container, contamination with any harmful substance, for example bacteria, chemicals, inadequate pasteurization, presence of foreign substances, product mislabeled, failure to meet company's own specifications, food solids content below legal minimum, damaged or unsealed container, defects identified by sight. Some of these defects are the first to be observed by the consumer and, if serious, may lead to rejection of the product. Eye appeal is an important attribute of the product as well as its container. Defective container. Numerous problems may be identified, including soiled containers with either dirt or ice cream on the exterior of the package, dented, torn or otherwise damaged containers, unsealed or improperly sealed container, improperly or illegibly coded, inferior packaging material, misshapen container, etc. Product appearance. Packages may be over or underfilled, which are defects traceable to the filling operation in the plant. However, the product may also be bulging due to the changes in atmospheric pressure when product is transported from a low to a high elevation, or it may be pulling away from the sides and top of the container and appears to be shrunken. High overrun and heat shock accentuates both problems. Although shrinkage may occur for no apparent reason and just as mysteriously go away. It seems to be related to some subtle condition in the milk proteins, because changing the source of MSNF sometimes stops an outbreak of shrinkage. The color and appearance are largely defined by the ice cream manufacturers who make the product. They decide whether to use artificial colors and their type and intensity. They also select the fruit, nuts, candy and variegating syrups and control the concentration of each to be used. The appearance should conform to the manufacturer's design from one run to the next. If an illustration of the product appears on the container, the ice cream should look reasonably the same. Generally, the color should be appealing, compatible with the flavor and not artificial looking. Most common color defects are too light, too intense, uneven and unnatural. The last implies that the color is not compatible with the flavor. For example, a lemon color in a peach-flavored ice cream. Added ingredients like fruit, nut particles and syrups, etc. should be of desired size, uniformly distributed at the desired density, not icy, and their color should not be bleeding into the surrounding ice cream. Meltdown characteristics of ice cream. These are observed by the consumer when a serving is not completely consumed. Products may vary in the rate of meltdown and the appearance of the melted portion. Ideally, ice cream should melt to a liquid of the consistency of the mix from which it was made. An old ice cream or one that has been highly stabilized tends to melt slower. Stabilizers and emulsifiers also affect the appearance of the meltdown, which may be curdy, foamy or actually separated into clear whey. A buttery meltdown may result when the ice cream has churned in the freezer. Whey separation may also be observed in the undisturbed mix due to the same causes and when air has been incorporated during processing. The addition of approved food-grade stabilizing salts may affect the meltdown. Defects of texture. The aim is to produce an ice cream with a smooth, creamy texture consistent with an internal structure made up of small ice crystals and small air cells. There should be no discontinuity of the internal structure perceptible to the consumer as excessive coldness, ice crystals, sugar crystals or relatively large masses of churned butter. Sugar crystals large enough to be perceptible do not melt as rapidly as ice in the mouth and thus impart a sandy texture. Smaller undissolved particles may be perceived as chalkiness or astringency. Many steps in the manufacture of ice cream are aimed directly at promoting a smooth textured product. For example, use of stabilizers and emulsifiers, high solids content, fast freezing, fast hardening, etc. However, The ice crystals begin to grow in size as soon as the ice cream is made, and it is the rate of growth that must be controlled by the choice of proper ingredients and the avoidance of heat shock. Defects in texture due to ice crystals are described as cold, coarse, and icy. The presence of other undissolved particles produces a chalky or sandy texture. The use of excessive emulsifier or ineffective homogenization gives rise to a buttery texture. Defects in body. The type of body desired in the ice cream is an option that the manufacturer can exercise. The principal contributors to the body are the solid content stabilizer and emulsifier and overrun. An ice cream body may be too heavy, excessively chewy, or resistant to bite, too weak, quick disappearance in the mouth due to low solids, high overrun or inadequate stabilization, crumbly, lacking cohesiveness due to high overrun, low solids or ineffective stabilization, short, similar to crumbly and usually caused by high overrun. When scrapped, the ice cream lifts up in relatively thin layers and thus lacks cohesiveness. Too dry both in appearance and mouthfeel, solids content and certain stabilizers and emulsifiers, or gummy due to overstabilization. Flavor defects. Flavor defects may be impacted by any of the ingredients, but some may also develop in the mix or the ice cream. A logical division of the various defects is based on their source because it is along these lines that corrective measures must be sought. Some defects will appear under more than one source. Defects contributed by the dairy ingredients. Any off-layer present in the milk product may be reasonably expected to appear in the ice cream, although mild defects such as slight feed, slight cooked or slight fat would be of little consequence or undetectable. More serious off-layers to be guarded against are high acid. This is one of the defects caused by bacteria when, due to favorable temperature and length of storage, they are given an opportunity to multiply. Depending on the specific bacteria present, the acid development may be accompanied by other off-flavors of an unpleasant and generally unclean character. Some acid-producing bacteria also produce a malty flavor. Old ingredient. There are several types of old ingredient flavor. Dehydrated products may become stale due to chemical changes. Fluid dairy products may subject to bacterial action as in the high acid flavor or when psychotropic bacteria are active. These bacteria produce off flavors described as fruity, unclean, bitter, putrid, rancid, etc. Unclean. When the flavor suggests unsanitary conditions or has a barny character, its generic description is unclean. The term is aptly chosen because of the unpleasant aftertaste which persists after the sample has been tested. Oxidized. Cardboardy, tallowy, and stale metallic are the other terms used to describe this off flavor. Fat oxidation that leads to the development of oxidized flavor proceeds more rapidly in the presence of copper or iron contamination. Products intended to have a long storage life, that is, dehydrated products, butter, sweetened condensed milk, are also susceptible. Once the off flavor develops, it continues to get worse, which makes it even more serious. Some milk supplies are particularly susceptible to oxidation. Dry lot feeding of cows has been shown to be one responsible factor. Another form of oxidation occurs when milk is exposed to sunlight and fluorescent light of low wavelength. It is caused by the oxidation of a protein component and is identified as a cabbage or burnt feathers-like flavor. Rancid. The enzyme lipase is normally found in milk and under conditions of excessive agitation, foam formation and alternate warming and cooling catalyzes the breakdown of the fat. The free fatty acids that are liberated, butyric, caproic, caprilic, capric, and lauric acids, produce the off flavor which has been variously described as soapy, goaty, bitter, stale, coconut-like, and perspiration-like. Pasteurization inactivates the enzyme. Mixing of raw milk with homogenized products can initiate the off-flavor production. Homogenization of a product containing active lipase may produce rancidity in a very short time. Cooked. There are several variants of the cooked flavor. The milder form is simply described as cooked or custard-like. The more unpleasant variants are caramelized, scorched, burnt or scalded. High heat NDM, sweetened condensed milk, evaporated milk, ingredients that have turned brown due to caramelization or Maillard reaction, or ingredients processed at high temperatures when considerable burn-on occurred on the heating surfaces are the possible causes of the defect. Whey. When whey is used as an ingredient, its flavor quality should be carefully checked. Any off flavors present will very likely appear in the ice cream. Foreign. This represents a serious category of defects caused by the contamination of the ingredient by a substance completely foreign to food material. The substances may be sanitizers, detergents, pesticides, paints, lubricants, etc. Quality surveillance of ingredients must discover such problems and reject the ingredient from use. Defects due to mix, processing and storage. During processing, the mix is susceptible to the development of a cooked flavor. Foreign flavors may also gain access to the mix from the equipment, carelessness on the part of the plant workers or from the plant environment. If the mix is stored any length of time, it may deteriorate in much the same manner as milk, cream and other perishable products. Off flavors may be caused by bacterial action, oxidation or absorption of odors from the surroundings, including foreign odors. Defects due to flavoring materials. The quality of flavoring materials must be constantly monitored to ensure that it conforms to the product's design. Difficulties may be encountered with commingling of different flavors when one flavored ice cream follows another in freezing and packaging. The flavoring material may have the desired characteristics, but the imparted flavor may lack perfection due to an excessive or inadequate intensity. The flavor may be slightly lacking in blend or be a little harsh, in which case one may criticize it as lacking fine flavor. If the flavor is uncharacteristic or artificial-like, it can be labeled as unnatural. Other specific shortcomings may be identified by descriptive terminology. For instance, fruits may lack tartness, chocolate may be too bitter, nuts may be rancid, and citrus may have a peel flavor. Defects due to sweetening agents. In addition to being excessive or deficient, sweetness can also be uncharacteristic. A syrupy flavor suggests caramelization. It may detract from the fine flavor of the flavoring ingredients, particularly vanilla. Defective syrups may also impart a fermented flavor to the ice cream. Defects due to storage of ice cream. On storage, the flavor of ice cream may undergo chemical changes and the product may absorb odors from the surrounding atmosphere. The flavor may lack the luster of the fresh product, inevident, and the criticism becomes storage flavor. Oxidation may also take place, giving rise to an oxidized flavor. When the frozen storage facility experiences an ammonia leak, the consequences generally lead to the product being pulled from distribution and discarded. So, this was all about ice cream. I hope you enjoyed the lecture. Thanks for watching.